Good morning to everyone. So today topic is a pumping lemma for regular languages. So pumping lemma is used to prove that the language is not a regular. So everyone know about what is a regular language. It's nothing but in the language accepted by a finite automata. So everyone know the property of finite automata. So, design the regular language for the finite automata, that is known as a regular language. Though the pumping lemma is used to prove that the language is not a regular. It cannot be used to prove that a language is regular. So only used for is not a regular. So the word pumping is the meaning of generating many input strings. So the pumping means generating many input strings by pushing a symbol, by pushing a particular symbol in an input string repeatedly. So it generates so many input strings. Check each strings are present in the regular language or not. That is known as a pumping lemma. So once again, the pumping lemma is used to prove that a language is not regular. The regular language accepted only by finite automata. So this is the algorithm for pumping lemma. So a theorem, a language, a regular language is A has a pumping length P such that any string S where the length of the S always greater than the length of pumping lemma. This is the first condition. So the given strings divided into three parts X, Y, Z such that the following condition must be true in pumping lemma. The first rule, the given string is divided into three parts X, Y, Z, then apply the power for Y only for any value of I. The I value must be greater than 0 or equal to 0. Your second condition, the length of y must be greater than 0. The last condition, multiplications of x and y, its length always less than p. These are the three conditions for proving given regular language it's not a pumping lemma. So following 9 steps are used to prove a given language is not a regular. Step 1. Assume that a language is regular. The first step, assume a particular language A is a regular. Step 2, it have a pumping length P. All strings longer than P can be pumped. The first condition, all the strings longer than P. Then fourth step, find the string S. You have to pick any string S. The only condition, the length of the S, it's always greater than the pumping length. So when the first condition is okay, we divide the string S into three strings, three substrings X, Y, Z. Now we show that X, Y power I, Z. We apply I value from 0 to any number. The output string not present in the regular language. We want to show that. So we apply each value from 0 to n values applied to I. You get new strings. Check the new strings are present or not in our regular language. So then consider how S can be divided into X, Y, Z. We can divide X, Y, Z in multiple formats. Shows that none of the above strings satisfies all the three pumping conditions simultaneously. So S cannot be popped. S cannot be popped. That is known as contradiction. Now we see about one simple example. So this is the pumping lemma example. Proof that a language A power n, B power n is my language. It's not regular. Okay. So assume that A is a regular and has a pumping length P. This is step 1. Consider the given language is a regular, has the length of P. So the given strings is modified as string S equal to A power P and B power P. Now divide the S into three parts X, Y, Z. Assume the value of p equal to 7. We take any values 3, 2, 1, any value we can take for p. So when we apply the value p in my string s equal to 7a 7b, the starting condition a value equal to b values. So number of times are same. This is my string s. Now we divide the s into 3 parts for case 1. Now I divide the string s into 3 parts x, y, z. So I value 2, number of character 2, and y value number of 4a, z value 1a 7b's. Okay. Now I apply the I value 2. So when I equal to 2, so what is my new strings? AA. So y value 4a. So the 4a repeated in 2 times. So number of a's for y 8. So number of b 7. So total number of a is equal to 11. The number of b equal to 7. So this is not in my language. So my language number of a is equal to number of b. This is my language. But the new strings number of a is different from number of b. So the given string not present in my language. So the language is not a regular. We can divide the given string in any type. So in case 2, I divide the string x, y, z in the format of here. Here we apply the same value I equal to 2. I get a value equal to 7, b value is equal to 11. So number of a repeat 7 times, number of b repeat in 11 times. So they are different. So the language, that means this string will not lie in our language. We can divide the strings in this format also. Case 3 format, triple A, double P, then 5A. Here also I apply the I value equal to 2. Here the number of A equal to 8 times, the number of B equal to 9 times. Here also number of A not equal to number of B. Therefore, these strings will not lie in our regular language. So finally,